This is Mr. Beck Does Your Homework. This is AP Physics, homework number 9.1, question 13. Two identical small charged spheres hang in equilibrium with equal masses as shown in the figure. The length of the strings are equal and the angle shown in the figure with the vertical is identical. So they're both 4 degrees off or minus 4 degrees off of the vertical. Find the magnitude of the charge on each sphere. So what I have here is some triangles and free body diagram. So free body diagram of this one on the left is going to tell me that I've got a gravitational force this way, I've got a tension force this way, and I've got an electrical force this way. And I know that the relationship between the electric and the gravity is going to be a tangent relationship because these two have to add up to this one, or the opposite of this one. So if I were to draw this triangle, I could have my force of tension here, I could have my force of gravity here, I could have my force electric here. I'm given this angle, so I know that the tangent of the angle is going to be opposite over adjacent is going to be my force electric divided by my force gravity. So given this, and I know my force of gravity because I've got my mass and the acceleration of gravity, so I know this one. My tan theta, I'm given my theta, so I know that one. I am looking for the charge on each sphere. So my force electric is what I'm going to have to figure out. And my force electric is going to be K Q1 Q2 over R squared. R is what I don't know. I don't know the charges either, but I'm going to solve for the force here because I know my tan theta and my gravity. So I'll have this. My K I know. My R, well, if that's 4 degrees, can I figure out what this is if this is 0.15 meters? So I've got another triangle here that's 0.15 meters. I'm going to draw this as a separate triangle because this is a force triangle, this is a distance triangle. This is what I'm looking for. So if this is my theta, 4 degrees, and this is my 0.15, this distance here, which is going to be half of R, so I know that half of R is going to be 0.15 times opposite over hypotenuse is sine is the opposite over hypotenuse. So sine theta. So if I double my 0.15 sine theta, I will get the distance between the two charges because I got one there, and that'll give me R. So now I know this, and I know this, and I know this, and I'm looking for this. And remember, this is going to be Q1, Q2. If they're identical, it's Q squared. So from that should be enough hint for you to solve that problem.